Hello everyone. Now I'm going to talk about waiting lines. There are waiting lines everywhere. The thing about waiting line is anytime there is more customer demand than the service, the waiting line occurs. Now to clarify the thing about customers. Customers can be either humans or objects. Examples of objects that must wait in lines can be a machine waiting for repair, a customer order waiting for processing, even electronic messages. The thing about waiting line is if the level of service is low, then the customers will be dissatisfied. On the other hand, if the level of service is really high, the cost for the company will be really high. In that case, we need to calculate the optimum level of service. Now let's talk about customer populations. Customers populations can be finite or infinite. The finite population means the number of potential new customer is affected by the number of customers already in the system. And infinite customer population means the number of potential new customers is not affected by the number of customers already in the system. There are three types of behaviors that can occur in the customer. They are barking, reneging, or jockeying. Barking means the waiting line is so long, the customer gets discouraged and he or she decides not to enter the waiting line. Reneging means the customer enters the line, waits for a while, but decides to exit before being served. Jockeying means the customer enters one line and then switches to a different line in an effort to reduce the waiting time. The worst type of behavior is jockeying here. Now we are going to talk about the service system. Firstly, the number of waiting lines. Waiting line systems can have single or multiple lines. Banks often have single lines for customers. Customers wait in line until a teller is free and then proceed to that teller's position. Other examples of single line systems include airline counters, rental car counters, restaurants, etc. The advantage of a single line is that the customer's perception of fairness in terms of equitable wait is same. The customer thinks that the single line system is fair. On the other hand, there can be multiple line systems. The multiple line configuration is appropriate when specialized servers are used or when space considerations make a single line inconvenient. For example, in a grocery store, some registers are express lanes for customers with a small number of items. The number of servers. System serving capacity is a function of the number of service facilities and server proficiency. In waiting line systems, the terms server and channel are used interchangeably. It is assumed that a server or channel can serve one customer at a time. Waiting systems are either single server or single channel or multiple server or multiple channel. Single server examples include small retail stores with a single checkout counter, a theater with a single person selling tickets and controlling admission into the show, or a ballroom with a single person controlling admission. Multi-server systems have parallel service providers offering the same services. Multi-server examples include grocery stores that have multiple cashiers, drive-through banks that have multiple drive-through windows, and gas stations with multiple gas pumps. The arrangement of the servers. Services require a single activity or a series of activities and are identified by the term phase. In a single phase system, the service is completed all at once, such as with a bank transaction or a grocery store checkout. In a multi-phase system, the service is completed in a series of steps, such as at a fast food restaurant with ordering, pay, and pickup windows, or in many manufacturing processes. These are some examples. The first one is single server, single phase. The next one is single server, multiple phase. And the next one is multiple server, single line, and single phase. These are some more examples. Multiple server, multiple line, and single phase. Multiple server and also multiple phase. In addition, some waiting line systems have a finite size of the waiting line. Sometimes this happens in multi-phase systems. For example, perhaps only 2 cars can physically fit between ordering and pay window of a fast food drive-thru. Finite size limitations can also occur in a single phase system and can be associated either with the physical system or with customer behavior. The example for the physical system can be a call center that has only a finite number of incoming phone lines. On the other hand, an example for customer behavior can be when a customer arrives and a certain number of people are already waiting. The customer chooses not to join the line. The arrival and service patterns. Waiting line models require an arrival rate and a service rate. The arrival rate specifies the average number of customers per time period. For example, a system may have 10 customers arrive on average each hour. The service rate specifies the average number of customers that can be serviced during a time period. The service rate is the capacity of the service system. If the number of customers you can serve per time period is less than the average number of customers arriving, the waiting line will grow infinitely. You will never catch up with the demand. It is the variability in arrival and service patterns that causes waiting lines. Lines form when several customers request service at approximately the same time. This surge of customers temporarily overloads the service system and a line develops. Waiting line models that assess the performance of service system usually assume that customers arrive according to Poisson probability distribution, and service times are described by an exponential distribution. The Poisson distribution specifies the probability that a certain number of customers will arrive in a given time period, such as per hour. The priority rules. A waiting line priority rules determines which customers serve next. A frequently used priority rule is first come, first served. This priority rule selects customers based on who has been waiting in the line for the longest time. Generally, customers consider first come, first served, as they think that this is the fairest method. However, it is not the only priority rule used. Other rules include best customers first, highest profit customers first, quickest service requirement first, largest service requirement first, or emergency first. The performance measure. The average number of customers waiting in line and in the system. The number of customers waiting in line can be interpreted in several ways. Short waiting lines can result from relatively constant customer arrivals, no major surges in demands, or from the organizations having excess capacity. On the other hand, long waiting lines can result from poor server efficiency, inadequate system capacity, and or significant surges in demand. The average time customers spend waiting and the average time a customer spends in the system. Customers often link long waits to poor quality service. When long waiting times occur, one option may be to change the demand pattern. That is, the company can offer discounts or better service at less busy time of the day or week. For example, a restaurant offers early bird diners a discount so that the demand is more level. The discount moves some demand from prime time dining hours to the less desired dining hours. If too much time is spent in the system, customers might perceive the competency of the service provider as poor. For example, the amount of time customers spend in line in the system at a retail checkout counter can be a result of a new employee not yet proficient at handling the transactions. The system utilization rate. Measuring capacity utilization shows the percentage of time the servers are busy. Management's goal is to have enough servers to ensure that waiting line is within allowable limits, but not so many servers as to be cost inefficient. The easiest waiting line model involves a single server, single line, and single phased waiting system. The following assumptions are made when we model this environment. The customers are patient, no barking, reneging, or jockeying, and they come from a population that can be considered infinite. The customer arrivals are described by a Poisson distribution with a mean arrival rate of lambda. This means that the time between successive customer arrival follows an exponential distribution with an average of 1 by lambda. The customer service rate is described by a Poisson distribution with a mean service rate of mu. This means that the service time for one customer follows an exponential distribution with an average of 1 by mu. The waiting line priority rule used is first come, first serve. Changing operational characteristics. After calculating the operating characteristics for a waiting line system, sometimes you need to change the system to alter its performance. Let's look at the type of changes you can make to the different elements of the waiting line system. Customer arrival rate. You can try to change arrival rates in a number of ways. For example, you can provide discounts or run special promotions during the non-peak hours to attract customers. Number and type of service facilities. You can either increase or decrease the number of server facilities. For example, a grocery store can easily change the number of cashiers open for business. The store increases the number of cashiers open when lines are too long. Changing the number of phases. You can use a multi-phase system where servers specialize in a portion of the total service rather than needing to know the entire service provided. Since a server has few tasks to learn, the individual server proficiency will improve. This actually goes back to the concept of division of labor. Server efficiency. You can improve server efficiency through process improvements or dedication of additional resources. For example, cashier accuracy and speed are improved through the use of scanners. Service speed can also be increased by dedicating additional resources. For example, if a grocery bagger is added at each cashier station, service speed will be improved and customers will flow through the system more quickly. Changing the priority rule. The priority rule determines who should be served next. There are priority rules other than first come first served. If you want to change priority rules, consider the impact on those customers who will wait longer. Changing the number of lines. Changing to a single line model from a multi-line model is most appropriate when the company is concerned about fairness for its customers. A single line ensures that customers do not jockey in an attempt to gain an advantage over another customer. In case of large-scale waiting line systems, various mathematical models are developed. As waiting line systems become more complex, especially as they involve more than one phase, concise mathematical formulas in general do not exist for system performance measures. In this case, discrete event simulation is used. These simulations are run to mimic the behavior of the system in reality. The process model simulation software is used. There are also other softwares. That's the end of this video. Thank you.